Good morning, OHS iPad Geometry Initiative class. This will be section 2.7, part A, or part 1, which is over flowcharts and paragraph proofs. So what we're going to be doing is going back and forth between two-column and flowchart, and the same thing with paragraph proofs on this one. So we're still dealing with proofs. The concept's exactly the same. I don't think you have to actually make up a proof on this one. You're going to be given one style of proof and have to turn it into a different style of proofs. And they're always going to refer it back to a two-column proof. So go ahead and write down the title and go ahead and answer number 5 in your notes at this point. And notice that the title pretty much gives this one away. We're going to write some flowchart and write some paragraph proofs. We're going to use geometric theorems and deductive reasoning. Alright, let's go ahead and get on here with this. So what is a flowchart proof? It uses boxes with statements and reasons listed by those boxes, and then shows arrows that shows the flow or structure of the proof. And it looks like we got a new theorem here, which looks to be a little typo right there, so I'm going to cross off one of those O's. It's a common segments theorem, which is given collinear points. Why, yes, collinear means on the same line again. A, B, C, and D, so it's kind of the diagram there as shown. It says that segment, or if segment AB is congruent to segment CD, then segment AC is congruent to segment BD. Alright, so notice if this is congruent to this, then this is congruent to this. So notice that's just the overlap that they're saying is congruent. Alright, what are we supposed to use here? It says use the given flowchart proof to write a two-column proof. So we're given this flowchart proof, and we're just supposed to turn it into a two-column proof. So it shouldn't be that hard. Everything's listed out there for us, just like it would be in a two-column proof, but it's just written a little different form there. So we're going to turn this into a little two-column proof right over here. So our statements are going to go right here, and our reasons on the other side. Alright, so let's follow the flow proof here. It looks like we're given that angle 2 and angle 3 are complementary. I'm just going to write that down. And they list me the reason right there with that box is given. And then the thing that follows it would be that the measure of angle 2 plus the measure of angle 3 equals 90. Probably should be degrees. And they give me the reason right there listed by the box. So I just copy it down over here. Definition of complementary angles. Alright, so I'm going to skip a little spot here and write my third statement and reason down. And I'm going to backtrack a little bit up to this because it looks like these two all connect right here. So I need this information before I get to that box. So I'm going to put angle 1 is congruent to angle 3, and that's by given again. And then 4, just following the arrow straight down here, would be the measure of angle 2 equals the measure of angle 3, which is definition of congruent angles. And now they all come together right here with a little substitution, which says that the measure of angle 2 plus the measure of angle 3 equals 90. I'm going to write substitution here. And then it looks like I'm down to the very end, which is angle 2 and angle 1 are complementary. And the reason should be given for that, which is definition of complementary angles. So everything is written out for you on these problems here. You just got to go from one form to the other form. So those two are the problems that the regular geometry class would be doing at this time. We're going to truck on here, and I think they're going to have us go the other direction, which is probably a little bit tougher than what we just did there. So we're supposed to use the given two-column proof to write a flowchart proof, and we're given that B is the midpoint of segment AC, and that 2 times the length of AB equals the length of AC. Makes sense. So if I multiply this times 2, it would be the length of AC. So reading through the two-column proof, looks like our first statement there is the given information. Then they're going to use the definition of midpoint, definition of congruent segments, segment addition postulate, and then substitution. So it looks like maybe these 3 are all connected here, and then this kind of comes on its own, but then this connects to both of those. And then last step there is just to simplify. Alright, so let's see. I need somewhere to write this at, so let's try and get a box up here real quick. Need it a little bit bigger, but we'll just try and go there real quick with it. Let's color it so we can write on it. Green. Yeah, green looks good. Let's go with that. Alright, so we're going to need some sort of little oval up here to start with. And we're going to list our given information there, which is B is the midpoint of segment AC. Now from that, and we're going to draw a little arrow from it, we're going to get another little oval here, which is that segment AB is congruent to segment BC, and that's, again, if we just look across, that's the definition of the midpoint. And now again, that is going to help us derive that AB is equal to BC, those two lengths, and that's the definition of congruent segments. Now this one kind of comes off on its own here, and then they kind of flow back together. So I'm going to put this one right here then, which is a segment addition postulate, which states that AB plus BC equals AC. So these two kind of come together now to give us that substitution. AB plus AB equals AC. So all I did was take this and plug it in for the BC down here. Right there to get that statement. And then we should probably put the substitution right in there. And then I would usually flow right on across there, but we're kind of running out of room for that last step. So I'm going to flow it right down here. Which is going to be 2AB equals AC, and all we did was add our like terms together. So just like adding 2 x's, if I have 1x plus 1x, it would be 2x, so this would be 2AB's. When I add those two together, it's going to equal that AC. And we just call that simplifying when we add stuff like terms. So we transferred the two-column proof into a paragraph, or not paragraph proof, sorry, a flowchart proof. I'm going to go ahead and end part 1 of this section 2.7 video. So Mr. Lane signing off from OHS High School. We'll catch you on the flip side.